Class is Mohr circle construction and finding the principal stresses and maximum shear stress by the application of the Mohr circle. Therefore, first we got the dimensions of the figure of the Mohr circle. Here given the tensile stresses on the two-dimensional object, where sigma x given is the 150 megapascal. Here 150 megapascal. Sigma y is also tensile, where 100 megapascal, 100 Newton per millimeter square. As per conversion of the 1 Newton per millimeter square is equal to 1 megapascal. Now the tau xy, which is the shear stresses, which is applicable on the overall of the area, then it will act to rotate the object as like clockwise direction. And in calculation, our full calculation, we take the clockwise direction is taken as positive and anti-clockwise direction is taken as negative. Therefore, we first calculate the principal stresses. Principal stresses formula already I have discussed previous lecture, where applying the Mohr circle we got the principal stresses sigma 1 and sigma 2, which is the value is sigma x plus sigma y by 2. Here sigma x and opposite, which both are the perpendicular axis, sigma x and sigma y by 2, plus minus root under sigma x minus sigma y by 2 whole square plus tau xy whole square, which is the shear stresses. This value is 65 megapascal. Now putting the all values, I like the first sigma 1, which is the maximum normal principal stresses. We are getting the positive value of the root under of these values, where applying this, the 150 plus 100 by 2 plus root under 150 minus 100 by 2 whole square plus 65 whole square. Then we calculate the all mathematical calculations. As a result, 195 megapascal, we got the first principal normal stresses. Then we got again 62 sigma 2. This value is applying the sigma x plus sigma y by 2 minus root under this value. Therefore, the value is 125 minus this root under value is 70. Then 125 minus 70 equal to 55 Newton per millimeter square or 55 megapascal, which is drawn at OG 655 megapascal in Mohr circle diagram, and 195 here, where the meeting point of the circle at abscissa sigma axis and tau is ordinate axis, where the first we ordinate the sigma and tau is abscissa. Therefore, we draw the first OA. This is the value is 150 megapascal on a sigma axis, 150 megapascal, and another is sigma y is 100 megapascal. Both are positive. Therefore, both dimensions are taking right side from the origin O. Okay? Are you understood? Okay. Now, and this is the vertical lines which is drawn both sides, are the downwards and upwards. These downward directions of the vertical lines, which is shows the tensile stresses sigma x2 downward. This is shown the shear stresses tau, which is the downward direction, which is 65 megapascal, and here left hand side, this is the upward direction is the positive 65 megapascal. Here nomenclature of the sign convention sign convention, upward direction of the shear stresses is positive, and below the sigma axis, this is the downward direction is negative. Tau xy is equal to 65 megapascal, negative. Then we join the 2 points here. From the 150 to 65 is drawn here. Then we got a B point. From A is downward position is B, and from C to upward position is D. Then we got 2 points B and D, and we join the 2 points and make a straight line of BD, which is the diameter of the Mohr circle. Mohr's circle. BD is the diameter of the Mohr circle. At a time, this is drawn as like a BD. At a time, the O sigma along the abscissa, it will cut at a point. Which is cut point is at shown is E. This is the center of the Mohr circle. We construct a circle. With respect to the center of circle, and cut at the abscissa of the O sigma axis, and cut O sigma axis at point F and G. And this is the F and G. From O to F, this value is the sigma 1, which is the maximum value, which is finding out from the calculations 195 megapascal. And we draw the 195, which is the extreme point of the sigma axis, and sigma 2, which is the smallest point from OG, which is also the 55, and both are the positive value. Then both principal stresses are in positive in nature. Therefore, we calculate the tau maximum. This tau maximum is the value is sigma x minus sigma y whole square and tau xy. Then we put the value of the 65 whole square. After calculation, we got this is the same value of the root under here. Then this value is 70 megapascal. Therefore, tau maximum, which is EI equal to 70 MPa, which is at the point of here. Tau maximum is equal to 70 MPa. Here also 70 MPa, which is the extreme positions of the along the ordinate axis of the circumference of the circle. And now get tan 2 theta equal to tau xy sigma x minus sigma y. Tan 2 theta tau 2 tau xy sigma x minus sigma y. Okay. Now the 2 into tau xy equal to 65, sigma x is equal to 150 minus 100. Then we calculate 130 divide 50. Then how much angle? Then 0 is cancelled. 5 to 13, 5 2s are this. Now the value is tan 2 theta equal to 2.6. Therefore 2 theta equal to tan inverse 2.36. Therefore the value is 69 degree, and divided by 2, theta equal to divided by 2 is the angle 69 divided by 2, then 34.5 degree from x axis, which is shown is here. This is the x axis, this is the y axis. Then the principal stress is sigma 1, which is inclined from the x axis, is 34.5 degree. Now the principal stress is 34.55 degree. Thank you.